Next is a subspace of vector space. All of you know vector space. What is a vector space? Vector space is a set. That set satisfies some of the conditions under addition and scalar multiplication also satisfied. Scalar multiplication and some properties also satisfied. Then we can call it as that set will be a vector space over the scalar set. That scalar set we can call it as field. Okay, this is we know how to find a vector space. What is a vector space? What is the condition? All of we know. Next we can say subspace. What is a subspace? Subspace means a non-empty subset. A non-empty subset of S. First of all, we take a subset of V. V is a vector space. Then only we take a subset of V. That subset will be a subspace. Some condition. S satisfies some conditions. So V is a vector space. Then we take a subset of V. That subset will be a vector space. That S satisfies some conditions. Then only we can say S is a subspace of V. That conditions are S is a non-empty subset of V. S itself a vector space under addition and scalar multiplication. So subspace means S is a subset of V and S itself a vector space. That means S satisfies all the conditions of vector space. Then we can say S is a subspace of V. Understand? That is, S is a subset of V and S satisfies associative property. Second, commutative property. S has existence of 0. Zero element is also an element of S. Inverse also exists in S. And scalar terms. Alpha plus beta into x. X is an element of S, that is equal to alpha x plus beta x. Alpha beta x equal to alpha into beta x. Alpha beta coming from the scalar. Same scalar. Where we take a scalar for V, that scalar itself is scalar of S. So alpha beta is a scalar of V itself. So then these two conditions, then alpha x plus y equal to alpha x plus beta y. Then identity element also. These 8 conditions satisfied a subset of V. That subset, then only that subset will be a subspace. But these conditions satisfaction checking means some difficult, some trouble. So we only check that subspace criteria. We only check that S is a subset of V if S satisfies xy element of S implies that addition is also in S. Second one is scalar multiplication is closed. Then once more condition, identity of addition exists in S. We only check that these 3 conditions. These 3 conditions is satisfied. S satisfied these 3 conditions. Then we can say S is a vector subspace. of V. Because we already satisfies all 8 conditions. So S is a subset of V. S also satisfied these 8 conditions: associativity, commutativity, all conditions. But we only check that considering set have 0 element. And considering set is a closed under addition and scalar multiplication. These 3 conditions only we need to check. Then we can say S is a subspace of V. So this is the criteria for subspace. Criteria for subspace. Then 0 element is always subspace of V, and V itself subspace. So we know given a vector space, we have 2 subspaces. One is trivial subspace and one is V itself. This is called trivial subspace. 0 space called trivial subspace, and V itself is subspace. Okay. Other subspaces are there. That's are we need to construct, or that's are we need to find out. But any given vector space has 2 subsets. Always existed 2 subspace. One is trivial and one is itself. Okay.